sugar in it kind of dropped to the bottom of the foil of the container.
Mm-hmm.
I was like,
Now, now, go ahead.
Oh my bad. The way that the sugar is dissolved in the water, it was weird because when the other stuff went in, it like came back out.
So how do you think you could relate that to something in, if the sugar was a real contaminant, right? How, it really kind of puts in perspective how it spreads, where it goes, right? It doesn't just stay in one spot.
Like microplastics in like the ocean and like oil.
Yep.
And then, yeah.
You've got the tides, right, into currents, and so it's easily spread. Some may stay in place. Then we talked about the cost of it, right? How much does something like this cost? So we did the experiment on a smaller scale, giving you obviously a smaller scale cost to each of these items, from the materials you need to remediate the contamination and then the disposal, because once you have removed the contamination, now you've got a bunch of, whether it's, in this case, cotton pads and paper towels, but soil and absorbent materials that have absorbent qualities that now have these contaminants in it. So you can't just take it to a regular landfill. You can't, just toss it in the trash can. They've got to go to special places, and that generally comes with a cost, right? So did you find, when you were doing your cost analysis, were you surprised, or did you kind of expect the cost that you came up with?
I expected it.
I was actually pretty surprised because I thought it would be cost for like I don't know if we were gonna break the halfway point, but we were pretty close to our budget.
Okay. So you said some were surprised and some kind of expected it because they knew it would be expensive, right? Were any of you able to keep it under the estimated cost of disposal?
yes, my was able to.
Yeah. How did you manage? Like, what was your methodology to manage that?
We kind of spent like minimal like amounts of money on like items so that we could have enough for like all the labor, just to like make sure we don't break that budget.
And so you spent minimal items on material to say, like, basically what's the minimum you needed to save that cost for labor and disposal. Is that what you said?
Yeah.
Yeah. So were you able to clean up your site with the minimum amount of materials?
Yeah, pretty much, pretty well, yeah.
Yeah.
We spent around like, I want to say 2K to 2.5K on the material. And I want to say it took us like 4 minutes, around like $4,000 for labor.
Okay. Now, whose was the most expensive?
Yes.
Yeah, all right. Oh, no, it's just because we spent like a long time on physical labor, which cost us a lot in the end, and it kind of caught up with us without us really seeing how we're doing. And it probably took us by surprise.
Now, why was your labor so long?
I mean, I don't know, it's just the kind of trial and error, and we just trying to do the best we could.
Right. So what's something, if you could do it over again, what's something you would change to try and adjust the cost or the time that it took, which essentially relates to cost?
I would definitely use better preparation. I'd take more time preparing our objective, and that would mostly be it.
How much you got saved?
Yeah, we went around 8,000. It was kind of than the average, but yeah, I just definitely prepare more. We did it.
So prepare more, kind of get a plan in order before you actually start the work itself, right?
Yes, ma'am.
All right, so we talked about the cost. Did any of you at the end, when, excuse me, you measured, and I don't know how if it was just the pan or if you did this if you were able to measure the difference. But were you able to see, I know one of you said you almost cleaned it up. did some of you get complete cleanup results?
Our group was pretty close. We had like, less than, like, I want to say like 1/8 of the oil. Maybe less. We didn't have that much oil then.
Okay, and now were you one of the groups that were able to stay under budget or at budget?
Yeah, we were the one that costed us, 6K.
Okay, awesome. Now, the ones that spent a lot of money, did any of you find that your method was not very efficient, meaning you had a lot of material left and you spent a lot of money?
I feel that, you could have been better. I think we just,
No, no, more than half hour.
we got more than half out, but we could have done a lot better time than we had. Yeah, I just feel like if done again, we do a lot better. Yeah.
Again, goes back to that planning, right? Getting all the, kind of looking at what you've got, assessing the scenario, figuring out what are the best materials, how are you going to clean it up, and then executing that plan so that you can save your time and efficiency, and then hopefully you have enough materials to then clean up the spill or the contamination that you guys have. So I know we talked a little bit about, I don't know, it doesn't look like you guys, if you guys finished it up last week. So if you could change, I know some of you said you would plan, but other than planning, if you could change something within the remediation process, what is there something you thought of that wasn't in the experiment that you think would have been better to clean it up?
I feel like it would have been more helpful if we like exactly knew what we were going into. And knows most of us in the class, it was our first time doing something like this. I feel like it would have been more helpful watching someone else do it and see how the process goes.
Okay. Anybody else?
Maybe like, some sort of like filter, like, I don't know, like, for like, called coffee,
Like a coffee filter?
yeah, like a coffee filter, like, you know, like, I mean,
That makes it too easy, right?
yeah,
Alright.
something like that.
Probably should be still.
Or what?
You don't have to think.
So coffee filters, some different materials, maybe knowing, so having some expectations of how to do it. So that's sort of what's interesting in the real world, you know. I mean, obviously there have been spills and contaminations and there is sort of a process now depending on the material that's in the soil or in the water. But imagine if you were the first person to have to clean something up, or maybe it's a material or a chemical compound that's never been spilled before. So you are the first person, you know, there is some trial and error to kind of figure out what's the best methodology. And that's sort of the fun part of being an engineer is the thought of and the problem solving of how do I do this, right? How do I get rid of this contaminant? Or how can I make it better? How can I be more efficient? Are these materials that we've used for this experiment or in this process all along, are those the best materials? Has something new been invented on the market that maybe is cost effective, but also, or maybe it's not cost effective, but it works twice as fast and twice as better, right? And so therefore it ends up maybe not necessarily being cheaper, but you get a better cleanup for the same price. So those are kind of some things as an engineer you really start to think about, you know, and solving problems. Are any of you in the room thinking about engineering? Yeah, what kind? Mechanical? Is that what you said?
Just about.
Okay, who's the other one?
Oh, mechanical.
Mechanical? All right, what do you like about mechanical engineering?
I don't know, my grandpa did it, and I just thought it was kind of interesting. Yeah.
So in the remediation site, you know, there's lots of different types of engineers that kind of come into play. What's something that you could see the mechanical engineer being in charge of?
Um, um, I'm not really sure. No, not really.
Do you think that there's various types of equipment or pumps or anything like that that might need to be sized? So, you can't just take, a small pump and expect to pump out the water or contaminant in a very large lake, right? In a timely manner, because we've just learned time is money, right? So mechanical engineers have to size the pumps to make sure that they're the right size for the job and that they have enough horsepower, right? So that's something a mechanical engineer could do. Yeah. Let's see.
I have a quick question for them.
Yeah.
When they were talking about the process, how many of y'all would consider changing the order you do things? Because most of y'all put soap in first before you started any dredging and stuff. Didn't y'all consider after the fact if you change the order of stuff?
I think the dish soap helped separate it, which I felt like that was more helpful, getting it all to one side and then absorbing it, like, so you get, like, it's all together at once.
Okay.
But
I just didn't
I
know if
agree
y'all.
with that thing.
Okay, fair enough.
So I just have, let's see, I've got a couple more slides and then you guys can ask all the questions you want. So the cleanup process in general that we use by what we call the super fund, excuse me, applies to pretty much most any contaminated site throughout the world, both water and soil. So you've got the discovery, hey, there's something going on. We've got a contaminant in the soil. We got to investigate. We got to figure out what it is. And then we have to assess it, right? Where is the contamination? How big is it? Does it spread? Is it in the water? Is it a plume? And is it in a groundwater? Is there a tide component? Is it in a river? What kind of animals is it going to affect? Is it going to affect people, plants? What are, basically assessing the entire situation to figure out what is best, right? Then you go in and you figure out the remediation portion of it. And you do a feasibility study. What kind of remediation should we do? Which one's the best one? Is it cost efficient? Is it the most effective? All those things we've talked about through this experiment. Then you've got your action plan, the cleanup, you design the cleanup, and then you get out there and do it. So back to thinking about what it is. How do we solve this problem? Let's get an action plan. Let's write it out, and then let's tackle the job, because then you can make sure that it gets cleaned up, it's cost efficient, and it does its job, right? Then they monitor it for years, depending on the contaminant and the type of site. They'll monitor it until there is no more contaminants in the soil or the water or whatever it is. And then eventually, if they determine it's been cleaned up, it'll come off the Superfund list, and it's not considered a Superfund site anymore. Did you guys have a chance to look up any sites in or near where you are that may be Superfunds or used to be?
I did.
You did not?
Oh,
That's okay. So go ahead.
I didn't know that was gonna help both our situation.
Yeah, in hindsight, maybe that would have been good.
That wasn't gonna go.
Like a good stepping stone to like do our own thing, And yeah, maybe we just should have done that. That's something like.
Well, that's okay. You can still look it up out of curiosity and kind of explore. Being in the railroad industry, one thing that we use is that you see a lot are wooden ties, right? So that's what's underneath the track, and the track is held on with spikes to those railroad ties, and those railroad ties are soaked in what's called creosote. And what that does is it helps protect the ties. They last, 40 something years. It protects it from insects, from wood rot, and it really actually helps with the weight of the train kind of absorb that shock, and so that they don't splinter and split and decompose it more rapidly, because time and money to, replace these ties, the railroads don't want to be doing it all the time. But the problem with that is creosote can end up in the ground. So there actually was a creosote plant. Can't remember the town in Texas off the top of my head, but and this has been years ago, but it is a Superfund site, and because of the chemicals that have leached into the ground. Now, anytime you clean up or do a project on railroad property, they always take and over excavate some of the soils, and they test it to make sure that these contaminants haven't leached into the ground. So, even kind of being proactive rather than waiting for that problem to arise, and then it has to become a Superfund site. It's mitigating that risk throughout the life cycle of whatever it is you're doing. So for many railroads, it's miles, thousands and thousands, tens of thousands of miles of track across the country. So they always make sure that they test for stuff like that. And then they take it to the appropriate sites. Because like we mentioned, we don't want to just take it to any landfill. You don't want to dump it in your backyard. We're not going to build dirt bike tracks with it. You know, it's contaminated and it should be disposed of and treated properly.
When they dispose it, do they recycle it?
Do they recycle it?
Like, can it be recycled? Or no?
You mean the dirt?
Yeah,
Generally they take it to a facility that again, depending on the contaminant, where they kind of air it out or they treat it accordingly and just contain it. But they don't, from my understanding, they don't reuse it anywhere. So some of the effects that contaminated sites can have on people, you know, depending on the chemical, they can have huge impacts on our quality of life. It can lead to illnesses like cancer, high blood pressure, birth defects. Contaminated land can harm your livelihood. So think about if it was farmland and you're growing food there, you know, your food and your animals that are eating those crops and eating that food that can come into play, and then you are eating it, and it can also cause illness that way. Or maybe the livestock or the crops don't make it, you know, and that's also the farmers suffer from that as well. All right, so now for the sort of fun part. Actually, this is all fun. Do you guys have any questions for myself as an engineer? Go ahead.
so you know how we had to like take the tray and pour the water into the thing so that the oil and the water would separate? Can that ever be like recreated? And like if you're cleaning like an actual like lake or something? Like it's not like I'm not saying like, oh, you pick up the whole lake and pour it out, but like do they ever like get like a helicopter and just like scoop up water? Something like that.
Like to take a sample of an area to see how effective
Yeah.
they've been.
Like,
I guess
just, like,
it depends. Yeah, maybe like the accessibility. You might need a helicopter like to go scoop to test it. I don't know if that is a method they would use for like remediation in the water.
like some groups lost more oil doing that. That's why. I was wondering.
Yeah, and it might be a cost thing. So, you know, I mean, there's those helicopters that help kind of the opposite where they're with wildfires and stuff. So they have water or planes and then they release that or release some sort of substance to help squash the fire. But I'm just thinking from a cost standpoint and then the how much water weighs and the amount of water you'd have to take out. Could a helicopter realistically get that done in a reasonable amount of trips and time? I mean, I don't know, you know, that might be it might be a cost barrier on that.
Interesting.
Good.
Oh, why did you choose your major?
Why did I choose my major?
Yeah.
So for some reason, I don't know, I don't have any engineers in my family. So I just always wanted to be an engineer. I love math. I love science. I like problem solving and trying to figure out ways to make something not necessarily better, but how to figure out how to solve it besides just whatever everybody else has done. And my original intent was going to go into construction and help manage construction projects. So civil engineering, because I like to watch things being built. So civil engineering was kind of the pathway to that. And I don't know. I love it. I mean, I don't know. The railroad industry has been, it's a very unique industry. It's not something most people think of, but getting to go out on site and watching what you see on paper put into reality, it's kind of rewarding. You know, and you can drive around town and go, yeah, I helped with that project. I helped with that project. So getting to see your work in real life.
That's awesome.
It is pretty cool. Yeah, go ahead.
What are some, wait, no, how do you manage your time between, engineering and other activities on campus? Or like, how did you manage your time through like college and like other activities, I guess, outside of college?
Yeah, so I think the main thing is prioritization because, so I went to Georgia Tech. It's a pretty demanding engineering school. We usually rank top 3 for most engineering programs year after year. And so it's demanding and it's not easy, but you do gotta prioritize. So maybe that means if your friends say, hey, let's go grab pizza, and you have a chemistry test the next day, maybe pizza isn't such a good idea if you're not prepared for your test. So it's just learning to figure out that, what's the order you need to do things in, because you can't do everything, right? But you got to do what's important.
How many, like,
Go ahead.
how many, like classes did you have like for like each semester? Did you have like 4 or did you have like a lot?
3 or 4 per semester. There was one my senior semester, I had 21 hours. So I think I took like, what is that, 5 or so classes. So, yeah, I took about 15 hours each one, which in college it's, 3 or 4 credits per class. So it totals anywhere between 12, 15, 18 hours, somewhere in there. So, yeah, I think about 5 minutes or a little less than 5 minutes. I'll take a couple more questions. Yep, go ahead.
When did you decide that you wanted to be an engineer?
I don't know. I just remember always wanting to be one.
Mm.
I know. And there's not a whole lot of women in engineering. So I think a lot of people were surprised, especially this has been years ago. So, but it's fun. Yep.
When did you discover engineering?
Well, I think I discovered the concept because my dad, although he wasn't an engineer, he was a chemistry and physics major. He would take our car apart just for fun and put it back together. So I think seeing him do that was the realization that, this actually something along these lines of thinking could be fun. Yep.
Well, what is the major difference between high school and college?
Learning how to manage your own time. So in high school, you've got teachers saying, hey, you've got that assignment due. Hey, you've got mom and dad or grandma or whoever saying, hey, get up, make sure you're at class, make sure you do this. And the one thing you're going to have to learn in college is how to manage your own time. And that can be a challenge, but it can be done. So it's better to start now and develop really good habits so that you can take those to college with you. Yep, I think it's time for one more. Yep, go ahead.
Do you know anyone that does like geological engineering?
Like geotech?
Yeah.
Yeah, I've got a few friends that do that. I always joke around, they like to play with the soil. And they help make sure things are stable, or for us in the railroad industry, make sure that we can put the track there, put the yards there, that's suitable soil for it. So yeah, is that something you're interested in? Maybe. I said, is that something you're interested in?
Oh,
Maybe.
no, well, I want to do paleontology, and I feel like geology that would be like in case I wanted to like change direction, that would maybe one of the things.
Yeah.
But
Awesome.
how long did you have to go to school for your major?
Yeah. Yeah, well, the first couple years of school, you guys are getting in college, you're getting your basic classes anyway, so you'll figure it out. And honestly, it's okay if you start out doing one thing and you switch to something else. Find your passion, and you will enjoy every single day of your career. So, well, thank you guys. This has been great.
Well,
Thank you.
thank you so much, Mr. Mangoya's class. I hope you guys have a
6 or 7 years old.
fabulous afternoon. Mr. Dixon will send you this recording,
Great.
and we look forward to your next lab session.
All right, great. Thank you.
Thank you.
Yeah.
Thank